Okay guys, so over the last couple of days we've been looking at different types of parallelograms, specific types of parallelograms and their rules. Today we're going to add two more types of quadrilaterals. We're going to do kites and trapezoids, and we're going to put everything we've learned from topic 22 into one flow chart. If you look at the back of your unit plan, you'll notice that topic 22F says organize the properties of a quadrilateral into a Venn diagram or other graphic organizer or outline. So I know we've already done a Venn diagram with just parallelograms. We're now going to do a flow chart or something resembling a flow chart for all of our quadrilaterals. So we're helping you work on that. So if you want to do this at the top of your paper, go ahead and put topic 22 A through D, comma, F. Oopsies. Okay, so A through D is everything like the properties that we're learning, and F is being able to put it all together in some kind of graphic organizer. So that's what we're going to do now. Go ahead and put your name here too so you don't lose this. These are your notes, and you need to keep these. These will be a part of a binder check. So that being said, let's just start with a header that says quadrilaterals. Because that's really what this whole topic is about. In red, I'm going to do definitions, and in green, I'm going to do properties. So what is a quadrilateral? And I'll just maybe put this here. Okay, so a quadrilateral is a polygon, which is a multiple-sided figure, with 4 sides. And by now, a property that you should know is that the sum of the interior angles is 360 degrees. So in green, we're going to be doing our properties. Things that you need to know about that shape. So we have quadrilaterals. A quadrilateral is a polygon with 4 sides, and the sum of the interior angles of that is going to be 360 degrees. Let's start with a review. So for our quiz that you guys have next class, or maybe you've taken the past and you're watching it later now, you need to memorize all of these definitions and all these properties. And if you look at the figures, a lot of times you can figure out those properties yourself, but you still need to memorize them. So I'm going to start by going over here, because the first thing that we spent a lot of time on was parallelograms. And we defined a parallelogram as a quadrilateral whose 2 pair of opposite sides are parallel. Well, that shouldn't come as a surprise, right? Parallelogram, it's in its name, right? Okay, and we've learned some properties. The first property that we have is that opposite sides are congruent. Our second property, here's our 2 angle properties, is that opposite angles are congruent. Our third property is that consecutive angles are supplementary. Okay. And our fourth property is that diagonals bisect each other. Okay, so there's our parallelograms. And then last class we said there's specific types of parallelograms, and there's kind of 2 breakoffs at this point. If we make all of the sides the same, we get a square, and if we make all the angles the same for a parallelogram, we get a rectangle. So here's my first one, and over here we get a rhombus. I think I might have accidentally said square before, sorry. So what is a rectangle? Well, if we look by a definition, it's a parallelogram whose 4 angles are congruent, and specifically they're each going to be 90 degrees. Okay. Now notice in the definition it says a parallelogram. That means everything that's happening here is also true for a rectangle. So it's a parallelogram whose four angles are congruent. Similarly, this is a quadrilateral. So everything that's true about quadrilaterals is also going to be true for parallelograms. So as you go down, everything above it is also true. Well, we had one new property for a rectangle. I really should say new properties, but that's okay. And our one new big property is that diagonals are congruent. Okay, so now we have a rhombus. And the definition for a rhombus is that it's a parallelogram whose four sides are congruent. And a rhombus has a couple of new properties. The first is that its diagonals are perpendicular. That's a symbol for perpendicular. It looks kind of like an upside down T. And then the second is that diagonals bisect angles. Or I should really say the diagonals bisect opposite angles. And since we've drawn pictures and talked about this before, I'm not going to draw pictures right now. But that's our two new properties for a rhombus. And if we put a rectangle and a rhombus together, we get to a square. Okay. And a square is a parallelogram whose four angles are congruent and whose four sides are congruent. Okay? Squares don't have any new properties other than it's a combination of both of these, so now everything above it is true for a square. So that's everything that we've learned so far about quadrilaterals. I'm sorry, this paper is kind of moving a little bit. Tried taping it to get it to stay in place. Maybe that's a little bit better now. Okay, so let's move on. This is our first type of quadrilateral. This is our first stem. The next thing we're going to learn about is trapezoids, which actually is just what we're going to learn about right now. Okay. And by definition, it is a quadrilateral with one pair of parallel sides. So why don't I draw a picture of that really fast? All we need to have a trapezoid is a quadrilateral where one pair of opposite sides are parallel. Take this piece of tape off. It's not working as well as I'd hoped. So that's all we have for a trapezoid. So we can actually get a little more specific though. And there's a specific type of trapezoid called an isosceles trapezoid. And the definition of an isosceles trapezoid is a trapezoid, which means everything above is true, right? So a trapezoid whose two legs are congruent. Or in other words, whose non-parallel sides are congruent. So let me draw a picture of that for you. Okay. There's my isosceles trapezoid. We already know because it's a trapezoid that these two sides are going to be parallel. Because it's an isosceles trapezoid, we also know that these two sides are going to be congruent. So far, this is a base. This thing up here is also called a base. And these two sides here are called our legs. Okay. When you have an isosceles trapezoid, this and this, those two base angles will be congruent, and these two base angles will be congruent. Okay, we call them base angles because these two angles are on the same base. Those two angles are on the same base. And because of same side interior angles, those two angles are going to be supplementary. So let's do some properties here. Base angles are congruent. Okay. And then I don't know the best way to talk about these. We could say maybe leg angles are supplementary. Would that make sense for you guys maybe? Or I guess in other words you could say like one of each type of base angles are supplementary. So why don't I just call it leg angles? That's not a phrase that people normally use. Base angles you'll see in your textbook. This isn't something you'll see, so I just want to make sure it's clear. Leg angles are supplementary because they are same side interior angles. Or in other words, I say because of the, let me actually do this, because of the same side interior angles theorem. So there's our isosceles trapezoid. I hope we're doing okay so far. We've got one new type of shape that we need to go. So notice we have our first train is with parallelograms, our second train is with trapezoids, and then our third one is for kite. Now, you might have noticed a pattern. Here we have two pair of opposite sides are parallel. Here, one set of opposite sides are parallel. For a kite, no set of opposite sides are going to be parallel. But that's not how we define a kite. The actual definition is going to be a quadrilateral with two pair of congruent consecutive sides. So for instance, I'm going to draw a picture. When you think of flying a kite, this is hopefully what you think of. Okay? Two pair of consecutive sides that are congruent. So these two sides are consecutive because they're next to each other. These two sides are consecutive because they're next to each other. And those two pairs have congruent sides. So a quadrilateral with two pairs of congruent consecutive sides. And it has a couple of properties. I'm going to write the properties first and then I'll show you in the picture. Okay. The first are perpendicular, just like a rhombus. And then the second thing I'm going to do is say maybe that it folds in half. This isn't a good property either in terms of it. You're not going to see this in the textbook, but I'm going to show you what I mean by that. So the first thing was that if I have my diagonals, my two diagonals are going to be perpendicular. So all four of these angles are going to be 90 degrees. Now, unlike a rhombus, not all of your angles are going to get bisected, but some of them are. For instance, this angle right here is going to be the same as this angle right here. Because when I fold it in half, like you can kind of see, I'm literally going to flip this half onto it because that side's going to match up with that side's going to match up with that side. This half of the angle is going to match up with that half of the angle. This whole angle is going to match up with this whole angle. And then this little angle is going to match up with this little angle. I tried to put one tick mark each there, one arc, and then 3 arcs down there, and then 2 here and here. So our property, the fancy properties of the diagonals are perpendicular. But something that's really important to know is that literally if you fold it in half so that the two sides, the pairs that go together, lay on top of each other, all of the angles are going to match up as well. So these are going to get bisected, this angle is going to get bisected, and then these two angles are going to match up. So if you look at this, it is kind of a lot of information, but we need you guys to understand you need to memorize all these. You're not going to be given this on a quiz or a test. And the reason you need to know all these rules is when we give you a problem where you have to solve for angles or solve for diagonal lengths or solve for side lengths. So for instance here, I could give you this angle is 100, and you would need to know that this angle here was also 100, right? I would need to be able to tell you that maybe this was 50 degrees, and you would need to be able to solve that this was 130 degrees. Or I could tell you that this leg was 10 kilometers or miles or centimeters. You would have to know that this is the same. It's also going to be 10 kilometers, miles, centimeters, whatever I say it is. So you need to know these rules. You have a quiz next class, assuming you're watching this the day before, on all of these things. So you need to make sure you memorize them. Take your time writing this down and make sure you really understand it before you move on to the topic 22, kites and trapezoids worksheet. And then after that, you're going to work on a practice quiz.